Okay, so just a quick algebra review on writing equations of lines. And if you remember, there are three forms of a line. Just refresh your memory really quickly on those. The first is slope-intercept, and that's the first one you ever learned. It's your favorite y equals mx plus b. The second is point slope. And that one is pretty useful. We're actually going to use that twice down here, so I'll show you that in a minute and remind you of the equation for that. And then the last one is standard form, which is not all that useful, especially when you're trying to write the equation of a line. It's usually you have to write it in one of these two. So you start here, and then you can go to standard form. However, it is helpful in Algebra 2 when you get there for solving systems of equations. We will review at the bottom how to put things in standard form once you have them in one of these other two, but it's really not going to play a big part in geometry. Okay, so to write an equation of a line, there's a couple different situations that can happen, and depending on what information you're given, you should use a different pathway to write the equation. So if you are given the slope and the y-intercept, then based on the names of your line forms, you probably want to use the slope-intercept form. So that's what you'll use, slope-intercept. And as a reminder, that is y equals mx plus b, where m is the slope and b is the y-intercept value. So we're going to do a quick example. Write the equation of a line with a slope of 3/2 through the point 0, 3. Now you may be saying, wait, they didn't tell me it was a y-intercept. But if you see a point and the x value is 0, then you know that's the y-intercept, because on the coordinate graph, if the x value is 0, then you know you're somewhere on the y-axis. So any point that you pick on the y-axis has an x-coordinate of 0. So in this case, we have 0, 3, so that's up here somewhere. Okay, so we're simply going to plug these in. This is a pretty easy situation. You plug this in for m, you plug this value in for b, and voila, we are done. That is the equation of our line. Awesome. And that's pretty easy to graph from as well, so there's no transformation needed. This is a pretty simple type of situation. Okay, now we get a little bit more difficult, but not bad at all. So in this case, if you were given the slope and a regular point, then you want to use point slope form. And if you remember, that is y minus y1 equals m x minus x1, where we're going to plug in for y1, m, and x1 with the point that we're given. Oops, sorry. You don't have to put parentheses around these. This is just, this would be the normal equation. I'm just putting parentheses to remind you of what it is, like I did on this one up there. Okay, so when you know the slope already and you know the point, you can plug it straight in. So we just plug and chug. We do y minus 5, because that's the y coordinate, equals 3x minus -1, which becomes x plus 1. From here, so this is the perfectly acceptable point slope form. From here, if we wanted to get it into graphing form, for graphing purposes, you usually want to put it in slope-intercept form. So that would mean distributing this 3 and also adding the 5. So I'm going to do that. Y equals 3x. This would be plus 3. Then I'd have to add plus 5. That becomes plus 8. So from this, we know that our slope is 3 and our y-intercept is 8. So either of these are acceptable answers if you're asked to write the equation of the line, but this one would be used for graphing. All right, And the last situation that happens is you are given 2 points. And this is probably the most complex case where you have to go through a couple of steps in order to get the equation of the line. So the first thing you have to do is find the slope. Once you find the slope, you choose 1 point and put into point slope. Then you distribute and solve for y. And then voila, you are in slope intercept form, which is ideal for graphing. Those are the 4 steps in order to be able to graph a line if you're given 2 points. However, you could stop here if you were just asked for the equation of a line because it would already be in point slope form. I don't know why I left out the E there. Who knows? Okay, so if we follow those steps, if we were given these 2 points, -2, 5, and 1, 2, as an example, A, I would want to find the slope. So M equals 5 minus 2 over -2 minus 1. And in that case, that is 3 over -3 or -1. That's my slope. That's all of part A. Part B, we would put this and choosing one of my points into point slope form. I'm just going to choose the first one. It's pretty easy. So y minus 5 equals -1, because that's where the slope goes, times x plus 2. And I'm doing plus 2, not -2, because it's minus a negative for this. Okay, so that's part B. Part C would involve distributing here and then solving for y. So let me distribute first. I would get -x minus 2. And then I'm going to get y all by itself. And we'll be in part D then, which is slope-intercept form. Y equals -x. If I added 5 to both sides, I would get plus 3. And there's my equation of a line. Now, like I said, you could stop at this point if you were just asked to write the equation of the line, but if you want to graph it, it should be in slope-intercept form. Okay, oh, no, we're going to review really quickly how you would get from either of these to standard form. So it's pretty easy from slope-intercept to get to standard form. Just remember that standard form, let me write up here, standard form has a couple of stipulations. The basic equation is ax plus by equals c, and we use capital letters for a reason, because there are no fractions or decimals, and that is why we have capital letters. In math, capital letters indicate whole numbers. And then also a, the coefficient in front of x, must be positive. Okay, so if we're going for standard form from slope-intercept, it's pretty easy. We're just going to move the x over, and we get x plus y equals 3. And if we look at that, that actually satisfies all of the stipulations for standard form. We have only whole numbers as coefficients, and the coefficient in front of x, which is an imaginary 1, is positive. You can also go from the point slope form that you did up here. It takes a little bit more work. You still have to distribute, and then you'd have to move all your terms over, and you could get it into ax plus by form. And that's it for this lesson. Make sure to watch the parallel and perpendicular lines video that also goes for today.